So this is section 8.2, which is about matrix solutions to linear systems. So in 8.1 we talked about how to solve systems of equations with the elimination method and the substitution method. But we're going to introduce another way that can sometimes be more quicker and more convenient, which is the matrix method for solving systems of equations. So a matrix is basically a rectangular array of numbers split up into columns and rows inside of a set of brackets. The plural of matrix is matrices, and we call the numbers that are inside the brackets the elements of the matrix. Now it is possible to take a matrix, take a system of equations and to turn it into what is called an augmented matrix. In this transformation, the coefficients in front of the variables form the columns of these rows, and then on the other side of the dotted line are the constant terms, the solutions here. Now, if a variable is missing, you put in a 0 for its coefficient. So here you kind of have two examples of taking a system of equations and turning it into a matrix. So this one would be 3, 1, 2, 31. 1, 1, 2, 19, 1, 3, 2, 25. This other one, on this top row, you'd have 1, 2, negative 5, negative 19. On the second row, you don't have any x's, so that's why you put a 0 there for the x's. And then you have 1, 3, 9. On the bottom row, you don't have any x's or any y's, so you put zeros in for both of those. And then you have a 1 and a 4. Okay. So that's kind of what we do. We take a system of equations, we rewrite it as a matrix. After we have it as a matrix, our goal is to get it into what is called row echelon form. Row echelon form is where we have a diagonal of 1s going from the upper left down and zeros underneath. Now, the rest of these things are going to be numbers. A, B, C, D, E, F. These are all going to be numbers of some kind. They can be any number. But to be in row echelon form, it has to have a 1 in this diagonal, and it has to have zeros underneath. Okay. Now, how do we get a matrix into this form? To do that, we perform what are called matrix row operations. And there are 3 basic row operations that we can actually perform. The first one is that 2 rows of a matrix can be interchanged, meaning I can switch row 1 and row 2, or I can switch row 1 and row 3, or I can switch row 2 and row 3. I'm allowed to switch the rows around. That is okay. 2, I can take the elements of a row and multiply them by a non-zero number. So I can take this row and I can say, hey, let's multiply all of it by 2. Or I could also say, hey, I want to divide by 2, as long as I remember that divide by 2 means the same thing as multiply by a half. And so I can say, hey, I want to divide this row by a number. The third thing we can do is we can multiply one row by a number and then add it into a second row. Okay. So I can say, hey, I want to take this top row and multiply it by 3 and then add it into this second row. And that's okay, that's allowed, that's fine. And so what we do is we perform these 3 operations, moving rows around, multiplying rows by a number, and multiplying a row by a number and adding it into another row in order to transform our matrix and get it into row echelon form. Generally speaking, when we do this, the first thing we do is we try to get a 1 up here in the upper left. Then, once we have that, we try to get zeros underneath. Then we get a 1 right here in the middle, and then we try to get a 0 underneath. And then lastly, we try to get a 1 down here. And that's just kind of the process that we usually follow. Now, we have symbols that kind of represent these operations we can perform on a matrix. This little arrow means interchange the rows. So we see R sub I, arrow R sub j, that means switch row I and row j. Okay. A number in front of R sub I means take that row I, multiply it by that number k. And then if you have k times R sub I plus R sub j, That means we're going to take row I, multiply it by the number k, and then add it into row j. So just to get you used to these row operations before we use them, we are going to just do a couple simple little examples. They're not too bad, just to help you get used to it. So we have a matrix here, 3, 18, negative 12, 21, 1, 2, negative 3, 5, negative 2, negative 3, 4, negative 6. And it asks us to perform these operations. So on this first one, we want to switch row 1 and 2. So I want to switch these two rows around. So what I'll have is 1, 2, negative 3, line 5. And then I'll have 3, 18, negative 12, and 21. And then negative 2, negative 3, 4, and negative 6. So that's what it looks like when I switch row 1 and row 2. Right. B asks us to do 1/3 times row 1. So we're going to take this top row and we're going to multiply it by 1/3. So 3 times 1/3 is 1. 18 times 1/3 is 6. Negative 12 times 1/3 is negative 4. 21 times 1/3 is 7. And then the rest of our rows stay the same. So there's our answer on that one. All right. Letter C asks us to do 2 times row 2 and add it into row 3. So row 1 and row 2 are going to stay the same. We're going to do 3, 18, negative 12, 21, 1, 2, negative 3, and 5. But now row 3 is going to change because we're taking 2 times row 2 and adding it into row 3. So what is 2 times 1? 2. And then plus negative 2, that gives us 0. What is 2 times 2? 4. 4 plus negative 3 is 1. What's 2 times negative 3? Negative 6. Plus 4 gives us negative 2. 2 times 5, that's 10. 10 plus negative 6 is 4. And so there's what we get. Notice row 2 didn't change. Okay? Even though we're multiplying row 2 by 2, that doesn't actually affect row 2. When we put it here into row 3, it only affects row 3. Okay? All right, so let's look at another one of these just so you can kind of get used to it. So now we have a matrix 4, 12, negative 28, 1, 6, negative 3, 7, negative 3, negative 2, 1, negative 9. The first one asks us to switch row 1 and row 2. So I'm just going to switch these two rows around. 1, 6, negative 3, 7, 4, 12, negative 28, negative 3, negative 2, 1, negative 9. So there is my answer. Okay. Letter B asks us to do 1/4 times row 1. So 4 times 1/4 would be 1. 12 times 1/4 would be 3. Negative 20 times 1/4 would be negative 5. And 8 times 1/4 would be 2. And then the rest of the rows stay the same. Our last one asks us to do 3 times row 2 and add it into row 3. So 4, 12, negative 20, and 8. 1, 6, negative 3, and 7. And then we got to finish what this last row is. So 3 times 1 is 3. 3 plus negative 3 is 0. 3 times 6 is 18. 18 plus negative 2 gives us 16. 3 times negative 3 gives us negative 9. Negative 9 plus 1 is negative 8. 3 times 7 gives us 21. 21 plus negative 9 gives us negative 12. So there's how it works. Actually, that should be positive 12, shouldn't it? Not negative 12, because the 7 was a positive. Okay. So, as I said, we're going to use these row operations to take our system of equations, turn it into a matrix, and then put it in row echelon form. So, again, first step is always to write your matrix. Take your coefficients and your constants, write your augmented matrix. Step 2, get it into row echelon form. Start by getting a 1 in the upper left-hand corner, then get zeros underneath. Once you have zeros underneath, put a 1 in this middle spot, then get a 0 underneath it, and then lastly get a 1 in the last spot, and then you'll be done. Once you've done this, once you've got it in this form, rewrite these equations. Take them from being a matrix back to being an equation. You'll end up with z equals some number, y plus some kind of z equals a number, and then x plus some kind of y plus some kind of z equals some kind of number. This last one, because you have z equals a number, you know what z is, so then you can substitute that back into this middle one and solve for y. And then once you have z and y, you can substitute back into this first one and solve for x. And so it's kind of an easy way to do this. Alright, so let's look at an example of this here. So we're asked in example 3 to use a matrix, use matrices here to solve this system. 3x plus y plus 2z equals 31. X plus y plus 2z equals 19. X plus 3y plus 2z equals 25. So I'm going to start by writing my matrix. For this top equation, I'm going to have 3, 1, 2, and then a line, and 31. For the second equation, I'm going to have 1, 1, 2, and then 19. For the next one, I'm going to have 1, 3, 2, and 25. Now that I have my matrix, the next step is I want a 1 up here. Now, there's two ways I could get the 1 up here. I could divide this equation here by 3, or I could switch this row with one of these other two rows. The operation that's easiest is just to switch rows, so I'm just going to switch row 1 and row 2. So if I take row 1 and I switch it with row 2, then what I now have is 1, 1, 2, 19, 3, 1, 2, 31, 1, 3, 2, and 25. So I have the 1 up here on the upper left, which is good. The next thing I want is to get a 1 underneath. So I'm going to leave the top row alone. I'm going to leave it as 1, 1, 2, 19. Now I want this to be a 0 here. To get this to be a 0, I need to take this top row and multiply it by some number so that when I add it to this row, it makes this a 0. Well, in order to get rid of this 3, I would need to have a negative 3. So I need to take this 1 and multiply it by a negative 3. So I'm going to do negative 3 times row 1, and I'm going to add it to row 2. So negative 3 times 1 gives me negative 3. Plus 3 gives me 0. Negative 3 times 1 gives me negative 3. Negative 3 plus 1 gives me negative 2. Negative 3 times 2 is negative 6. Negative 6 plus 2 is negative 4. And this is the one where I'd actually want to use my calculator. So pull it up here. I'm doing negative 3 times 19, and I'm going to add that to 31. It gives me negative 26. Okay. So now I have a 0 there. The next thing I need is a 0 here. Well, again, I want to take this top row, and I want to do something with it so that I can add it to this bottom row and make a 0 here. Well, to get rid of this 1, I would need a negative 1. Well, this is already a positive 1, so all I have to do is do negative row 1 and add it to row 3. So negative 1 plus 1 is 0. Negative 1 plus 3 is 2. Negative 2 plus 2 is 0. Negative 19 plus 25, that's going to give me a positive 6. Okay. The next thing I want is, now that I have a 1 and I have zeros underneath, the next thing is to get a 1 in this spot. To do that, I'm just going to take row 2 and I'm going to divide it by negative 2. So row 1 is staying the same, 1, 1, 2, 19. Row 3 is staying the same, 0, 2, 0, 6. But this row I'm going to divide everything by negative 2. So 0 divided by negative 2 is 0. Negative 2 divided by negative 2 is 1. Negative 4 divided by negative 2 is 2. And negative 26 divided by negative 2 is 13. So now I have a 1 right here. Next, I want to get a 0 underneath. Well, I'm going to take this second row and I'm going to multiply it by something to get rid of the 2 here in the third row. Well, to get rid of this 2, I would need a negative 2. So I need to take this 1 and multiply it by a negative 2. So negative 2 times row 2, add it into row 3. So row 1 stays the same, 1, 1, 2, 19. Row 2 stays the same, 0, 1, 2, and 13. Row 3 is going to change. Negative 2 times 0 is 0. 0 plus 0 is still 0. Negative 2 times 1 is negative 2. Negative 2 plus 2 is 0. Negative 2 times 2 is negative 4. Negative 4 plus 0 is negative 4. Negative 2 times 13, I'm going to do this one in the calculator here. Negative 2 times 13, and then I'm going to add that to 6. I get negative 20. Okay, so now I have a 0 there. The very last thing I have to do is make this last spot in the diagonal be a 1. To do that, all I have to do is take row 3 and divide it by negative 4. So row 1 stays the same, 1, 1, 2, 19. Row 2 stays the same, 0, 1, 2, and 13. Row 3, 0 divided by negative 4 is 0. 0 divided by negative 4 is 0. Negative 4 divided by negative 4 is 1. Negative 20 divided by negative 4 is 5. And so now we have it in row echelon form. We have the diagonals in the 1s here, and we have zeros underneath. So now what we're going to do is we're going to translate this back into equations. So this top line says x plus y plus 2z equals 19. This second row says y plus 2z equals 13. And this bottom row says z equals 5. So we already know that part of our answer is going to be z equals 5. But I need to find x and y. Well, take this z here that you found and plug it into this equation right here. Y plus 2 times 5 equals 13. Y plus 10 equals 13. Subtract the 10, you get y equals 3. Once you have that, take the z and plug it in up here, and also take the y and plug it in up here. X plus 3 plus 2 times 5 equals 19. X plus 3 plus 10 equals 19. X plus 13 equals 19. Move the 13 over. X equals 6. And so there's our solution to this system of equations. And again, you can check it by plugging it back in here to the original equations. 3 times 6 plus 3 plus 2 times 5, that does equal 31. 6 plus 3 plus 2 times 5, that does equal 19. 6 plus 3 times 3 plus 2 times 5, that does equal 25. So it does work in all three equations. We did it right. Okay. Now, here's something I am going to show you. Your calculator can actually do this matrix process for you. So if you hit second and then hit this x to the negative 1, it'll take you to the matrix menu. This first thing just tells you the names of your matrices. You want to actually go over to edit so that you can actually edit one of the matrices. And when you do this, it asks you for a size. Well, this refers to how many rows and columns it has. Our matrix has 3 rows, and it has 4 columns. And then all we have to do is just copy it in. So 3, 1, 2, 31. 1, 1, 2, 19. 1, 3, 2, 25. Okay, so now we have it in there. I'm going to hit second mode to quit. Then I'm going to hit second x to the negative 1 to go back to the matrix menu. And now you notice next to A it says 3 by 4. It's because now I actually have a matrix in there. There's actually a matrix stored in A. So now what I want to do is I want to go to Math, and I want to go down here until I get to this, REF. R is row, E is echelon, F is form. So this is row echelon form. So I pick that. Then I go back to my matrix menu, and I'm going to tell it what matrix to do row echelon on. I want to use matrix A, and I close my parentheses, and I hit enter, and it tells us exactly how they did it. Theirs looks a little different because they reduced it a little differently than we did. They have 1, and then 1/3, and then 2/3, and 10.33, which would be 31/3. And then they have 0, 1, 1/2, and 5.5, 5.5. And then notice they still have 0, 0, 1, and 5. So they ended up with the same last row as us, but they didn't switch the first and second row like we did. They just dealt with fractions the whole way through. And so that's why their rows look a little different for row 1 and 2, because they did the fractions and I stuck to whole numbers. But it would still work that way. It's still okay. So just be aware that, be understanding that your calculator can do this. It does have that capability. Let's look at another one. Oops, sorry, I scrolled too far. So we have 2x plus y plus 2z equals 18. X minus y plus 2z equals 9. X plus 2y minus z equals 6. So if we write this as a matrix, it would be 2, 1, 2, 18. 1, negative 1, 2, and 9. 1, 2, negative 1, and 6. All right. Now that we have it as a matrix, the first step is to get a 1 up here in the upper left-hand corner. I don't want to deal with fractions, so I'm going to just switch row 1 and 2 right off the bat. So I'm going to switch row 1 and row 2. And I'll have 1, negative 1, 2, 9. 2, 1, 2, 18, and 1, 2, negative 1, 6. Now that I have a 1 in the upper left corner, I want to get zeros underneath. So I am going to get rid of this 2 by doing negative 2 times row 1 and adding it to row 2. So row 1 stays the same, 1, negative 1, 2, and 9. Row 2 is going to change, so 1 times negative 2 is negative 2. Negative 2 plus 2 is 0. Negative 2 times negative 1 is positive 2. 2 plus 1 is 3. Negative 2 times 2 is negative 4. Negative 4 plus 2 is negative 2. Negative 2 times 9 is negative 18. Negative 18 plus 18 is 0. Then I need to get a 0 down here. To do that, I'm going to multiply row 1 by a negative and add it into row 3. So negative 1 plus 1 is 0. This will be a positive 1 plus 2 gives me 3. Negative 2 plus negative 1 gives me a negative 3. And then negative 9 plus 6 gives me a negative 3. Now, we have our 1 and we have zeros underneath. The next thing to do would be to get this to be a 1. Well, I could divide by 3, but that would involve a fraction here. And I don't want to do that. So instead what I'm going to do is I'm going to switch row 2 and row 3 right now to avoid the fractions. So 1, negative 1, 2, 9, 0, 3, negative 3, negative 3, 0, 3, negative 2, and 0. Then what I'm going to do is I'm going to take row 2 and divide it by 3. So 1, negative 1, 2, and 9. 0 divided by 3 is 0. 3 divided by 3 is 1. Negative 3 divided by 3 is negative 1. Negative 3 divided by 3 is negative 1. 0, 3, negative 2, and 0. So I've got my 1, I've got my zeros underneath. I now have a 1 here. I want to get a 0 underneath. So to make this be a 0, I'm going to take my row 2 and multiply it by negative 3 and add it into row 3. So row 1 will stay the same, 1, negative 1, 2, and 9. Row 2 will stay the same, 0, 1, negative 1, negative 1. And row 3 will become, let's see, negative 3 times 0 is 0, plus 0 is still 0. Negative 3 times 1 is negative 3, plus 3 is 0. Negative 3 times negative 1 gives you a positive 3. 3 plus negative 2 gives you a 1. Negative 3 times negative 1 gives you a positive 3. 3 plus 0 is 3. And then, hey look, this actually came out as a 1, so I don't have to do anything to make this a 1. It's already there. So now we're ready to retranslate this back into equations. So this top row would be x minus y plus 2z equals 9. The second row would be y minus z equals negative 1. And the last one would be z equals 3. Okay, so we already know part of our answer. Z is 3. To find the y, we just take that 3 and plug it back in up here. So y minus 3 equals negative 1. Add the 3 across. So y equals negative 1 plus 3, which is 2. And then to find the x, we take the z and plug in up here, and we take the y and plug in up here. And so we have x minus 2 plus 2 times 3 equals 9. So x minus 2 plus 6 equals 9. Combining those, we get x plus 4 equals 9. Move the 4 over, x equals 5. And so there is our answer, 5, 2, 3. And again, we can check it in the equation. 2 times 5 plus 2 plus 2 times 3, 18, which is what it's supposed to be. Second equation, 5 minus 2 plus 2 times 3 is 9. That's what it's supposed to be. Last equation, 5 plus 2 times 2 minus 3, 6, and that's what it's supposed to be. Now again, I showed you all the math here to get this in reduced row, or to get this in row echelon form, but we could have done it with the calculator. If we go into our matrix menu and edit our matrix, it's still 3 by 4, but we want to change the numbers. So now it is 2, 1, 2, 18, 1, negative 1, 2, and 9, and 1, 2, negative 1, and 6. Quit out of that. Go to our matrix menu and say, hey, let's go down and do row echelon form. And we'll put our matrix A in there. And you can see that their numbers are a little nasty because they didn't try to get whole numbers. So they have 1, 1/2, 1, and 9. For the second row, they have 0, 1, negative 2/3, and 0. And for the last row, they have 0, 0, 1, and 3. So again, their last row matches with ours. Their first two do not because they were okay with fractions. One thing I can point out, if you don't know that these decimals are fractions, you can always hit math and do number 1, and you can convert it into fractions for you. So 1, 1/2, 1, 9, 0, 1, negative 2/3, 0, 0, 0, 1, 3, and it works the same way. Okay. Now, part of the reason I'm showing you this calculator stuff is it's okay to do these 3 by 3 ones by hand, but when they get bigger than 3 by 3, they become really hard to do by hand, and so it's much easier to do them in the calculator. And that's part of the reason we have calculators, is to handle calculations like that that are a little too troublesome for doing by hand. And so that's what we're going to see here in the next example. Okay? If you look at this next example, this is an equation that has 4 variables, w, x, y, and z. So when we translate it into a matrix, it's a really huge matrix. The top one would be 2, 1, 3, negative 1, and 6. The next one would be 1, negative 1, 2, negative 2, and negative 1. The third one would be 1, negative 1, negative 1, 1, negative 4. And then the last one would be negative 1, 2, negative 2, negative 1, negative 7. Now, we could try and put this in row echelon form ourselves by hand, but again, it's much easier to do it with a calculator. Now, this is a bigger matrix, so when we go into our matrix menu, we're going to have to edit, and we're going to have to change the size. This now has 4 rows and 5 columns, so it is a 4 by 5 matrix. And then we just fill it in, so 2, 1, 3, negative 1, 6, 1, negative 1, 2, negative 2, negative 1, 1, negative 1, negative 1, 1, negative 4, and then negative 1, 2, negative 2, negative 1, negative 7. I usually like to, after I type it out, I like to go back and verify really quick that I did it right. Yep, mine's okay. So now that I have that, I'm going to go in here, I'm going to go over to math, tell it to do row echelon form on matrix A. And again, it's going to give me some decimals. I'm going to tell it to make these back into fractions for me. So if I write down what I have 1, 1/2, 3/2, negative 1/2, and 3. On the second row, 0, 1, negative 1/5. Negative 3/5 and negative 8/5. On row 3, 0, 0, 1. Negative 3/14. And 47/14. And then our last one, we got 0, 0, 0, 1. And last number is 3. So if we translate these back to equations, we have w plus 1/2 x plus 3/2 y. Oops, I wrote z instead of y. I don't know why. 3/2 y minus 1/2 z equals 3. X minus 1/5 y minus 3/5 z equals negative 8/5. Y minus 3/14 z equals 47/14. And then lastly, z equals 3. So in terms of our answer, we do know the z is 3, because that's our last one. To find the y, we're going to take this 3 and plug it in up here. So y minus 3 times 3 is 9/14 equals 47/14. Add that over, let's see, 9 plus 47, divide that by 14, we get 4. So y equals 4. Now that we have both of the y and z, we can plug up in here to get our x. So here for our x, we'll have x minus 1/5 times 4 minus 3/5 times 3 equals negative 8/5. So x minus 4/5 minus 9/5 equals negative 8/5. X minus 13/5 equals negative 8/5. Add that over. So we're going to have negative 8 plus 13 divided by 5. So x is equal to 1. And then lastly, now that we have x, y, and z, plug into the original equation and you can get w. Oops, I need to switch to a different color. So w plus 1/2 times 1 plus 3/2 times 4 minus 1/2 times 3 equals 3. So w plus 1/2 plus 12/2 minus 3/2 equals 3. W, let's see, 1/2 plus 12/2 is 13/2. Minus 3/2 is 10/2, which is the same thing as 5. So then move the 5 over. 3 minus 5 is negative 2. And so there is our answer for that system of equations. So again, calculators come in very useful here. So that way we don't have to do all of these steps to get it to this form first and then do all this work. We can just tell the calculator, hey, change this to this form, and then, hey, let's plug in and figure out what our answer is. Okay? Now, there's another one of these. I'm going to skip it because, again, it's the same kind of process. So what I want to move on to, though, is the other thing we can do. So before we've been doing row echelon, where we have a 1 in the diagonal and zeros underneath. But there's an even more simpler form, and this form is called reduced row echelon form. You have diagonals. You have a diagonal of 1s here. You have zeros underneath, and then you also get zeros on top. Now the nice thing about this is when you translate it back into your equations, this top row just says x equals a. The second row just says y equals b. And the last row just says z equals c. And so you basically get your answers without having to do any back substituting. All you have to do is just get it into this form. Now when you're doing it by hand, it works pretty much the same way. When you get here, okay, these steps all the way to here are the same steps as row echelon that we just did. You have 2 more steps though that you have to do. Okay. Once you get your 1 in the third column, then take that 1 and use it to make the rest of these numbers up above it be 0. Then do the same thing here. Take the 1 that's in the second row, second column, and use it to make this above it a 0. And that will get it into reduced row echelon form. And then that'll tell you what your answers are. Now, the nice thing is that the calculator can do this as well. So when we go here into our matrix menu and we look at the math, right underneath REF is RREF, which stands for reduced row echelon form. And so if we had done that on our previous example, hey look, there's our answers. Did we get negative 2, 1, 4, 3? Negative 2, 1, 4, 3. They match. Okay? So this is a nice way to easily get your answers. You just put the matrix into reduced row echelon form, and that'll tell you what your answers are. Oops, I did not mean to close that. I apologize. Let me open it back up real quick. So what we're going to do here is we're going to use reduced row echelon form to solve some equations. So I have 3, 1, 2, 31. I should be writing this down. 3, 1, 2, 31. 1, 1, 2, 19. And 1, 3, 2, 25. And so I'm going to go into my calculator. I'm going to go into my matrix menu. I'm going to go over here and edit my matrix. This time I have 3 rows and 4 columns, so it is a 3 by 4. And then I'm just going to put in my numbers. 3, 1, 2, 31. 1, 1, 2, 19. 1, 3, 2, 25. And I'll just check it really quick. That's fine, that's fine, that's fine. That's fine. Okay, so my matrix is all good. Once I've done that, then I'm going to say, hey, calculator, under math here, go down to reduced row echelon form, and then do that on matrix A. And there's my results. 1, 0, 0, 6, 0, 1, 0, 3, and 0, 0, 1, 5. So when we translate that back into equations, that says x equals 6, y equals 3, z equals 5. So the answer is 6, 3, 5. And again, you can check it. You can plug these answers back in here. It will work in all 3 equations. And so this is a much quicker way to do it. Okay. All right, let's do this one more time just so you can see it once more. So again, we have our matrix for this system of equations. This one is 1, 1, 1, 4, 1, negative 1, negative 1, 0, 1, negative 1, 1, 2. And so we're going to tell the calculator to put it in reduced row echelon form for us. So we're going to go into our matrices, we're going to edit it. It's still 3 by 4. So I have 1, 1, 1, 4, 1, negative 1, negative 1, 0, 1, negative 1, 1, and 2. I'm just verifying that all the stuff is correct. That looks good. So I'm going to quit. I'm going to go back to my matrix thing, go to math. I'm going to go down to reduced row echelon form. And then I'm going to pick matrix A. There we go, 1, 0, 0, 2. 0, 1, 0, 1. And 0, 0, 1, 1. So if we translate that back into equations, that's telling us that x equals 2, y equals 1, z equals 1. So the solution to this system is 2, 1, 1. And again, you could check it. You could plug it back in here and see that it works. So with the calculator, this is a pretty fast and easy way to solve a system of equations. It doesn't take a whole lot of work. So that's it for this section of notes. As always, if you have any questions, feel free to email me.